Find the slope of a function at a given point. Well, the slope of a function at a given point is called the instantaneous rate of change, and it forms a tangent line. Meaning, if I have this function right here, this red one, this right here is the instantaneous rate of change. At that point, this is the slope at that point of the graph. At this point, this is the slope of that graph. This yellow and blue are tangent lines for the function, red function. Now, what's interesting about tangent line is a slope with only one point. That is really not possible without the limit. So, if we look at this picture, this is called f. Now, it's a parabola. Now, this blue line is a secant line, and to find slope, don't you find rise over run? So, that would be slope. Now, if this coordinate is c, wouldn't this value be f of c? You plug c in for the x. Okay, this coordinate over here is h over. I went over h, just some, I don't know how far, just went over h. So this coordinate is over c plus h. C plus h more, so that's over c plus h. And the output would be f of c plus h more. So you're going to plug in whatever c was plus h more into the function of f. So those are your two coordinates. If you have those two coordinates, then we would say that the run is h and the rise is the difference of the y's, which would be f of c plus h minus f of c. Now to find slope, wouldn't you take this and divide by this, which is right here. That is a slope formula. This is slope of this picture. Now, well, what would happen if this dot kept getting closer and closer? You'd be getting closer to the, if this dot got closer and closer, sorry, on the green line to this dot right here, you'd be getting closer and closer for the secant to actually be the tangent line. What if it landed straight on top? That would mean your h would be 0. So if this dot lands straight on top, you would have an h of nothing, which you cannot divide by nothing. But with the limit, you can say, what if h was nothing? What if your change between these two dots is nothing and they're right on top of each other? The limit allows us to predict that and see what that would be. Because technically, you can't make a slope when you divide by 0. You have to have a change of something. You can't have a change of nothing. So, if we use this slope formula, and we take the limit as the change of this number gets closer and closer to nothing, when you do that, you create something called the derivative. It gives you the instantaneous rate of change. You do not need now an average of two dots. You have an instantaneous called a tangent line, a one-pointed slope. So if we were to use this formula and learn how to use that formula and what it does, you create a slope of, at one point, an instantaneous rate of change formula, which is your tangent line, these little things. And when we do that, I'm not going to show you how, but when we do this, we get this formula that creates derivatives, aka the slope at any time on a graph. For instance, the slope at this point is that blue line slope. The slope at this point is 0, which is the slope at that specific point. And then we come up with this word derivative. The derivative comes up. It is the name, okay, derivative creates another function that can find the slope of the original function at any given point. So if I want the slope at this point, that's what it looks like. The derivative will tell me the slope at that point. It'll tell me the slope at this point. If I put a dot right there, it would look like a slope like that, and it would tell me the slope at that point. The derivative tells me the slope at any given point on the graph, and the derivative comes from this slope formula using a limit, and that is the derivative. Derivative opens up all of calculus, and then if you take this deeper, if f of x is equal to x to the nth power, this little sign means derivative, meaning the slope function of it. Well, the derivative or slope function of f would just simply use this formula when you have this. So you basically take the power, see the power right here? You bring the power in front, see the n comes in front, and you drop the power by 1, so you minus 1 from the power. So if you take any function like this, and you apply this simple procedure, you create a function that creates slopes of any point on the original graph. And we call it f prime, which is the derivative function, which creates, again, slopes at any point on a graph. This is a very simple or basic introduction to what a derivative is. And derivative is what opens up everything in calculus.